So hi everyone, today is the first session, which is the introduction to machine learning algorithms. So we'll be getting started with first algorithm, that is linear regression. So let's get started. So the agenda is today is what is the linear regression. Next, we are going to understand the equation of linear regression, right? What is the equation of line and all. Next is we'll be going towards the graphical understanding of linear regression, because the data, we'll be plotting the data and we will be seeing how linear regression determines the best fit line for the data. Next, and the final is coded. So we'll be implementing linear regression on a data set that we will be creating in Python. So this is the agenda for today, and let's get started into the first step, that is what is linear regression. So what is linear regression simply means? So linear regression simply means we are using the line because it's linear, right? We are using the line to model the relationship between the dependent variable, that is your response / your output, and independent variables, that are your features. So we have some independent features, it can be anything, and we want to predict the output of something. So we are going to model the relationship between the dependent and the independent variable using the line. So that's what linear regression simply means. Next is let's get started into y is equal to mx plus c, as we all know is the equation of line, where m is the slope and x is your feature that is independent and it can take on any value, plus c is the intercept. So the line that will be fitting to the data is not always the line that will be passing through the origin, because that might not be the case, right? Because it can pass through origin or it can pass through some intercept that give us the best data set. So whatever I have explained you is, written here. So m is the slope, x is the independent variable, that is your feature that determines. C is your intercept, and next y is your dependent variable, that can be your response or you can say output, right? So this is the basic equation of line, and we are going to go deeper into this. So let's start. So the ideology for learning anything, I follow one simple approach, that is what is the input I have, what I have to process, and what is the output. So this is the basic three-step process that we do. So let's decode linear regression in using three simple steps, like what is the input. So input can be your feature. So feature, it's not necessary that it will be only one feature. It can be x1, x2, up to xn. Okay. Processes, we have to find a line that best fits the data. So how to find that line? That is your actual goal. Output is basically what we want to predict, right? Maybe I'll be taking one example to that. So in linear regression, the output is always going to be real valued. So I'll be also explaining you the classification problems, so in which the value will be a discrete, but in linear regression, one point we have to note is the value will be real valued, right? So this is the process that we are going to follow. We have input features, we have to find a line, and we have to generate the output, right? Now you might be thinking, how is the x variable, what can I put in x1, x2, x3, what are the real world examples, right? Or what is y actually? So let's map with the real world example. So suppose you want to buy a house, let's say the price of house you want to predict, right? So price of the house will be depending on the many features. It can be your where is the location, or where is the area, what is the area of the house, and so on. So let's stick on to one feature. So I have written here is price of house, y is equal to mx plus c, where price of house that we are interested in predicting, and x is basically the area of house that we have input, and that can vary, right? It can be any square feet area, and we want to predict the house price, right? So how can we, this is the real world example, and so we have to model this relationship using a line. So that's what is linear regression doing. We have to predict the price, we have one feature that is independent, and we have to model the relationship and find the line that best fits the data. So I hope I made it clear using the real world example. Now we have to go next is the graphical way. So I think graphs are a very good way to understand things because it's visual and it provides you greater capability. So I'm going graphical way now. So as you can see on the right hand side, it's a graph. X can be your right. We discussed. So it can be your square. What is the area? And Y is the price. So it can be anything. The values you can see are here in, just for simplicity purpose, I have taken 1, 2, 3, 4, 5, and so on like that. So the line that is, these red data points are the data that we already know, right? Linear regression is a supervised learning algorithm. So in supervised learning algorithm, we always have the data. We have X and we have the Y. Okay. Now these red data points represent our data. And now this blue line is the line that we are interested in finding, this line, because it will be easy to map. Now, what are these green lines? So green line is the main thing that we will be discussing now. So red data points are our data that we have already, as it is a supervised learning algorithm. Blue line is basically the best fit line that best fits your data. How we are going to find it will be checking out next. So X is a feature, say area of house, and Y is output, say price of house, right? So next is, now one question like how to determine a line is best or not. So linear regression is an algorithm that is doing that for us. So we have data, we are drawing a line, right? So now we have to draw another line. So now how to know, how to determine whether a line is best, whatever line is best or not. So linear regression algorithm internally is trying different lines. And now it is calculating, as you can see. So this is your data point, right? Now we start with a line, we plot one line. From the data point, we are calculating the distance of this data point from this line, right? Calculate the distance of this data point from this line and then square it. Why we are squaring it? Because the negative distances we don't want to be, cut by the positive distances. Okay, for example, 2 are positive and 2 are negative, and if the distance is same, so it will be 0, which we don't want. So what we are doing is we are calculating the distance of this data point from this line and squaring it, and then we are adding these distances. So let's say it's a D1, it's D2, it's D3, it's D4. So now we have D4 distances, and we want these distances to be minimized, because the distance of the data point from the line that linear regression proposed are called the residuals, and we want the residuals to be minimum, right? Residuals is basically the error, right, between the line that is used for prediction and your data points. I hope I made it clear. So how do we determine a line is best fit or not? So linear regression will be trying one line, another line, different lines, and calculating the distances, squaring it, and then try to choose the line which has the minimum residuals, the sum of square residuals, right? So this was it. I hope I made it clear. So what is the linear regression? Next is what is the equation of line? What are the different parameters? Then we did mapping to a real world example where X is the price of house. X is your area and Y is the price of house. Now we want to determine how linear regression is doing the graphical way. Now it's the time to code it, because we have learned everything for a linear regression simple model. So I'll be doing that in a Google Collaboratory, and now I'll be showing you that. So this is my linear regression, notebook that I've prepared now. So what I've done is simply here is I'm importing this NumPy library and this linear regression algorithm from this sklearn library. So that's I'll also be talking in the future lessons like what is the sklearn library and all, but we have imported this libraries. Next is we want some data, right? So why we want some data? So let's recap using our slides is so these are the 4 simple steps. So we have the data, to get the data first. Next is create the model. Next is fit the model and then get the prediction. So these 4 simple steps I'm going to do in the Google Collaborative Notebook. So I generated some random data. It is simply random. So I created an array of numbers that are simply random. I put, so you can take any numbers. Now what we have done is create the regression model. So you just have to write the linear regression and your model will be initialized. Now you have to fit. So you have your X, you have your Y. Now you have to fit this linear regression algorithm to your data, right? So what we have done is this my model dot fit your X and your Y. Next is, I have already told you that in linear regression, we are interested in finding the coefficient, that is your slope, plus intercept in determining the line that will be best fit for your data. So that also we can do by finding the slope and intercept. So this library, this model has this capability to do. You just have to write your model dot coefficient, your model dot intercept. So you got like 0.88. So whatever equation will be, y is equal to 0.88 into x plus 1.097. So I'll be writing here this, so you can get, because we are going to, y is equal to 0.883 multiply by x plus your c is 1.097. So you will be putting the x value, it will be doing this calculation and generating you the y. Using the model y, how it is generating, you just have to write for whatever array you want predictions for. So I have written like np.array, so it is 13 on 16. So I want to determine when my x is 13, what will be my y? When my x will be 16, what will be my y? So these kind of predictions you have to do in a single step, right? So this model dot, you just have to write model dot predict and pass this array and you got these predictions. So what we did, we just imported the libraries, we generated the data, we created the model, we fit the data that we generated above into the model, and now we have slope and intercept, and using this we can easily determine using a single function that is called predict, right? So we have simply used this predict function to generate the predictions for whatever values. So it cannot be like 1 or 2 or 5. You, in real world scenario, you want predictions for say 100 or 600, thousands, any kind of value you can provide, right? And then you can provide these predictions and save it using CSV, right? Save it into a CSV and then you can analyze the data, right? So this was all about linear regression implementation that we did in Python, starting from what is linear regression, how to modeling it, what are the different parameters and different, the graphical way plus this linear regression notebook. So congratulations, you successfully completed the linear regression and happy learning.